The broadcast is now starting. All attendees are in listen-only mode.
Hello everyone, good morning. This is Dave Nielsen. I'm about ready to get started here. Just going to do one last test check before we get going. And also let me move this into full screen mode. All right, I think we're all set. Great, okay, let's get started. Thank you for joining this webinar. This is going to be a talk about the 10 ways to scale with Redis. My name is Dave Nielsen. I head up community and ecosystem programs here at Redis Labs. I'm joining you from the beautiful neighborhoods of Mountain View and Silicon Valley, where our office is just off here on El Camino and 85, if you've ever been here to Silicon Valley. And it's a beautiful, cool day. And I got a nice view here. So I'm all set. Hope you are too. Again, thanks for joining us. Let's get going. Okay, so first of all, you guys all know Redis is a in-memory multi-model database, and there's lots of different ways you can use it. One thing I want you to know about is that I want to make sure you know, I got to tell everyone this, you can save your data to disk. That's part of how Redis works. It's one of the beautiful things that you set all this data up in memory, and when if something were to happen to your data or your server and it were to go down, then when you relaunch your server, you can reload your data with it. You can optionally persist your data also to SSDs as well, but that's with a Redis Enterprise product. So check that out. If you'd like to have large amounts of data in memory, we simply take part of that data, mostly the values, and we can persist them to SSD or flash. And as you know, Redis is very fast and it also scales linearly, mostly because there's a shared nothing architecture where you can have Redis essentially shard the keys and scale very linearly that way. And again, Redis Enterprise helps you with that as well. And Redis is much loved by developers, as Stack Overflow will tell you, because they've done a survey the last 3 years. Redis has come out as the most loved database. Why is that? It's because of performance. Everyone knows Redis is really fast. Not only is it a key value database, but it's also in memory, and it's very simple to use. 10 different data structures. We're going to talk about some of those today. And it's extendable also with Redis modules. So why is it so fast? Well, again, it's because it's in memory and it's NoSQL, and it really is much faster than all of the other databases. And you can see here, but let's keep moving here. I'm particularly happy and interested in the Redis data structures, which is mostly what we're going to talk about today. And if you don't recognize this image, it's from the 2001 Space Odyssey movie, where he looks inside the 1x3x9 black monolith and he sees all of these stars. Well, with Redis, it just seems like a key value database, but it's a lot more than that, because it's really a key and then data structure with 10 different data structures. And so that's when you look inside of Redis, you see all those interesting data structures. Here are the 10 data structures, plus also I don't want to leave out pubsub. We don't really consider it a data structure, but it is a unique piece of functionality. You've got strings, you've got sets, you've got bitmaps, you've got sorted sets, you've got bit fields, geospatial indexes, hashes, hyperlog logs, lists, streams, and again, pubsub. Lots of different ways to use Redis. And each one of these is fairly simple. So they have their own commands, and you just learn the commands and call them, and that's how you use Redis. It also has these modules, which are add-ons to Redis. They are fairly simple depending on the module. High performance, also give you the linear scalability and high availability. You can take a C program or Go or Rust, and you can create a module with it, leveraging existing data structures or creating your own. They can be used by anyone. We test and certify our Redis modules, and it gives you this multi-model capability with different modules, such as Redis Search, which is kind of maybe like a little bit like Elasticsearch, and Redis Time Series, which is a little bit maybe like InfluxDB, and Redis JSON, which again, a little bit like Mongo with its JSON document store. Rebloom gives you some probabilistic data structure capability, which is similar. It's sort of in the same category as a hyperlog log. And then Redis Graph, which gives you some graph capabilities, maybe similar to like a Neo4j. Anyway, there's a bunch of modules. You should definitely check them out. But what we're going to talk about more now is 10 different ways you can get started with Redis. We're going to go into some of these use cases here and a few more. These are generally what we consider to be the primary use cases for Redis, but there's, of course, many different ways to use Redis. And we're going to talk about some of these and a few more right now. All right, so managing session stores. Let's get started with that. But actually, before I do that, let's talk about the number one use case, which everyone knows, is caching. You just simply cache. So let's start with that, because that's the one that you should obviously know about if you don't already. That Redis gets used often as a cache for other databases or other data that takes a while to generate, maybe some output from a big web page or a long-running query or some other work that you want to do often, but it takes a while. You can perform that work and then store that in a key value, store that with a key and a value in Redis, and then quickly pull it out. And you can set the timeout to expire after a certain period of time so that Redis knows to then, the application knows that if the value is not in Redis, go regenerate that value and put it back in Redis for another time period. So that's the most popular one. But with session stores, it's also become very popular. And for those of you who aren't clear what I'm talking about, every single time you log into a website, you're giving it your user ID and password or some other credentials. And of course, you don't want to do that every time. So after you've done that, you take that information and you put it into like some sort of session variable. And then that means that the user doesn't have to log in every single time they come to your web page. They just simply see if that session has been set. Usually that matches up with a cookie, and then that information is stored in your database or somewhere that will your application will check every single time a user comes back to your website. So we're going to use a session store, a hash to store that information. But before we do, let me give you a little example of how this works. So you've got that data you've pulled out of your login, and a user can be somebody who's visited your website or somebody who's logged in. It can be either one. And then you can persist this information in a cookie that's created by your server and stored down on the browser, and the browser sends that cookie back every time you revisit the website. And then the server takes that information and stores it and will put some user session data that's useful there. So you're not constantly having to go back to the database to get things like the user ID and maybe the user homepage or some other information that's often used about the user. And you store that with in the Redis hash. Okay, and this data can be ephemeral, duplicated, it doesn't matter. Just make sure that it's useful data that you're using often. Okay, and so username, preferences, user preferences, the person's real name, other stateful data is what people typically put there. But with Redis, because it's so fast, you can also put additional information in there. You can take maybe notifications. Somebody's got an alert. You can track whether or not they've received the alert and pushed it down into your browser or not. You can track where they've been on the website and other information to help provide guidance, maybe where they need to go next, or recommendations or ads or anything else to create some personalization. So traditionally, in a simple world, you create your first website and somebody accesses it over the internet. And the request comes into your server, then you go to your database, and this is great to request the user information, your user session data from your database every single time. It's simple when it's low traffic, low volume. But over time, as the traffic grows, your server starts to struggle a little bit because that database is getting hit every single request just for that same information over and over again. And what you might do then is you might simply take that session information and store that session data actually in memory on the web server. It takes a little bit of the load off the database. But of course, this doesn't work so well because as you start to scale out, your server starts to struggle. You're going to scale out with multiple web servers. And now when the user comes in to visit the website, it might store the user session information on server 1, but then when they come back a second time, then they might be load balance redirected to server 3, and it doesn't have that information. So that's not a very good technique for scaling out your sessions. So instead, what you might do is set up a separate server for Redis, just like you have a separate server for your database, and then you will then store that user session information over on Redis, and this will take a lot of the load off of your database, and Redis is so fast that it's not going to add much delay to your own website, and now you can scale out just like you had hoped. So how are you going to do this? Well, the problem again is you want to maintain session state across multiple servers. You might have multiple session variables, and of course you want this to be high speed and low latency. We're going to use the Redis hash, which is perfect for this. You can use HMSet to let you save multiple field values or entries into one key value. And so we call these key value pairs. And then you can use HMGet to retrieve those values. And if you want to, there's lots of commands for hashes, such as hincrementBy or hincrementBy, kind of funny to say, to increment any of the fields. So if you're doing a hit counter, for example, or a page counter or something like that, where you want to track the number of times somebody's viewed an ad or a recommendation or hit a page, you can use that to increment just that one field in the hash. You can use the expire to delete the key after some timeout, usually like 20 minutes or something like that. So how does this work in your code? Here I'm showing you the commands that you might use from your command line. Of course, you're going to use a client library in your own your programming language, like Python or PHP or Java or something. You can go find out more about these commands at redis.io/commands #hash. And you would use HMSet. Here, I just want to explain this quickly. If you haven't done this before or seen this before, typically in Redis, what we do is we store the key as two pieces. One is the collection name or table name or whatever you would normally use as the word to categorize this type of key, and then you put a colon, and then you put the unique value. So in this case, it'd be the session would be unique, would be a 1. Obviously, session numbers would be much longer, or maybe you'd use the cookie token. But you separate them by the colon so that you can just keep things organized in Redis, because Redis is one giant namespace of keys. So then that's your key that you're going to look up is user session :1, and then you've got your name value or field value. So user ID might be 8754. The name is Dave. The IP address, and then the hit is at 1. And then you can use HMGet to get out multiple field values. You can see I'm again passing in that key, and then I've got the field that I want to request, user ID, name, IP, and hits. By the way, you can also use HSet or HGet to set just one field value or get just one field value. And then hincrementBy is what we talked about earlier, where you can increment the hits field by 1. And here you go, HSet, HGet, and HDelete if you want to set, get, or delete just one field. If you want to expire, set an expiration on this key. You can, in this case, we're setting it to 10 seconds. So expire user session :1 in 10 seconds. In 10 seconds, Redis will automatically remove that key, and it will no longer be there for you. And then you can also delete the whole key. All right, so I think we're starting to get the idea here how that hashes are storing a map of keys to values, just like a dictionary or an array, but faster. And this is great for using for session stores. Highly recommend this. Caching, session stores is going to, just those two use cases alone are going to get you really far. Okay, another one that's popular, managing queues with Redis lists. All right, so here's the problem. You've got, excuse me, you've got tasks that need to be worked on. Perhaps, like for one example, could be just a workflow. You know, you've got some user logs in or creates an account and there's multiple tasks that need to be performed. You probably don't want to wait until all those tasks are performed in order to reply back to the user and say, okay, your account is now set up. You might simply go create the unique ID, and then you know that you've got the main set of information there, but maybe like the user profile, photo, thumbprint, thumbnails, all that kind of stuff, they can be worked on and done, completed in the next couple seconds. So you can reply back to the user, but add that work into a queue. So you might have lots of items to be worked on, or you want to assign each one of them to a worker process and then remove them from the queue at the same time, make sure that's all done efficiently and fast. So this is sort of similar to buffering high-speed data. You can also use it for buffering high-speed data ingestion. So why is Redis great for this? Well, lists are perfect because you can use these commands, lpush and rpush, to add values to the beginning or the end of the queue. The L, by the way, stands for left, and the R stands for right. You know, you can decide which one of those is the beginning or the end. It doesn't really matter. But adding to one side of the list or the other, or popping from one side of the list or the other, is very fast. And then you can even have a command called, there's even a command called rpop lpush, which lets you pop an item from one end of one queue off and then push it to the beginning of another queue, all in one command. So you know when it replies back to you that it's been moved, that item has been moved. So here's an example of how you might make this work. You got a bunch of tasks you want to perform. So let's say we got task 1 in orange there. That would be lpush q1 task 1, and that's going to be added to your queue. That task might actually be some sort of ID or whatever information you need in order to perform that task. And then you're going to add that to your Q1, and then as you add more queues, it gets pushed towards the into the list, away from the edge. But there's always going to be something at the other end. You can even add to the right of it. Maybe you want to prioritize a task. You can add it to be next. And then you're going to continue on with rpop lpush to move the item from the right side of Q1 to the left side of Q2. It's very simple there. You can see how that works. And there's some other commands you can use, like to find the length of your queue, or if you want to pull out a particular item from in the index of the queue, or pull out a range of items from the queue. Okay, so let's move on to sets. Sets you can use sets for lots of different things. In this particular case, we're going to talk about using or managing tags, like user-generated tags or other metadata that you want to be unique about an item. And sets are great for this because sets have a key, just like all of Redis data structures. And then inside that key, you can store unique values only. But if you add a duplicate value, it just simply ignores it. Or if it's not there, it adds it. It's kind of like an upsert maybe. So then how does that work? Well, in this case, you want to have lots of tags. Sometimes you'll see items in a catalog, and you might end up with millions of tags. And what you want to do is you want to find items. In this particular case, we're going to use tags as sort of a quick and dirty recommendation system. So you might be viewing an item like an article on a website, and it has been tagged with multiple keywords, and you want to find other articles that have those same keywords. So you might click on that keyword, and it's going to then go and retrieve a list of all the articles. But you want this to be very fast because it's happening all the time. So this can also be used for similar purchases or blog posts, etc. Why is Redis perfect? As I mentioned before, sets are unique collections of strings, and they're very, very fast. You can use the SAD, S-A-D-D, set add command to add tags to an article, or to add articles to a tag. And we'll get to that in a minute. You can use sysmember to check to see if article has a particular tag, or S members to get all of the tags for an article. You can use sinter to find out which articles are tagged with particular tags. So tag 1, tag 2, or tag 77, or all three. And so, so then what would happen there is you think about Facebook when you go to see a user profile and it shows you not just all of their friends, but also your mutual friends. Well, perhaps, I don't know this, but perhaps Facebook is actually using sinter and taking two sets of user IDs, doing essentially a join or intersection between the two of them, and then giving you back just the ones where there are matching friend IDs, and then just displaying them to you. So that's how you might use this. Or what we're going to talk about right now is a use case where you have an article and it has tags. And so you can use sadd to have an article, key called article:1. And in that key, we're going to add 4 tags, tag 1, tag 22, 24, and 28. Now, with NoSQL databases, usually if you want to do lookups, that kind of thing, you end up storing the data twice. And this is so that you can look it up quicker and not have to do a join. So if you want to look up all the tags for an article, you can grab the key article:1 and get all of its tags. Or if you want to see which articles a tag belongs to, you can say, let's go get the key called tag:1, and it will return all of the articles that that have been tagged with that tag. So here you can see what we're doing is we're creating a new article called article:1. We're adding all the tags into the article:1 key, and then we're also creating a key for each one of the tags, and then we're adding the articles into that particular key. So that way we can look up a particular tag and see all of the articles that have been tagged with that tag. And so that's how you can do a quick and dirty recommendation system. And down below here, you can see we're using sinter to take the collection of values inside of key called tag:1 and intersect it with all of the values in the key called tag:2, and then it's going to return just the values that they both have. And then that would be a great way to recommend, hey, you're viewing tag:1 or an article with tag:1, let's go see what other articles you might recommend. Okay, so let's keep moving here. Let's take a look at leaderboards. Leaderboards are a very quick way quick in two ways, both extremely fast way to have a list of values that have some sort of order to them, but it's also easy to set up. It doesn't take many lines of code. And so the way this works is, let's say you are, probably the most popular use case would be a game company, and you have a massively multiplayer online role-playing game, and World of Warcraft or something like that, and you have millions of users simultaneously playing this game, and there's going to be some sort of leaderboard of all of their scores. Well, as they're playing the game, this leaderboard is changing quickly, and you can imagine just how much of a strain changing all the scores every couple of seconds is going to have on this data structure. And putting that data in an SQL table probably isn't even possible. So putting it in memory in a NoSQL data structure is possible. In fact, Redis does this quite well. So how does this work? Let's say you've got many users playing the game. You want to display the leaderboard in real time, and you want to know not just who's number 1 through 10, but you also want to know who's my nearest competition. So sorted sets are perfect for this. Excuse me. And what's going to happen is it's going to automatically keep track of the score for each entry in your key. So your key name is going to be the name of the leaderboard, :1 or something like that. And then you'll have a bunch of values with scores. And so the value might be the gamer ID, and then the score is incrementing as they achieve milestones. So, and you can use Z-add, Z-range, Z-reverse range, Z-rank, etc. And we'll show you how that works here. So let's say you've got a bunch of players. You've got game one, so that's your leaderboard, game one. And you've got an ID of 1, and you want to increment it by 10,000. So maybe as they perform a task or complete an action, they get 10,000 points. So you're going to see that user show up on the leaderboard at 10,000. And then you see user 2 gets 21 points. So you'll see them show up on the leaderboard. User 3, 34,000 points. And ID 4 gets 35,000. And now what you can do, if let's say user 3 gets to change the score, you can either override the score or you can increment it. Most likely you'll want to increment it. So you can see Z increment by user ID 3, give it another 10,000 points. And so it'll then move up on the board to be at 44,000. And you can pull out pull out particular ranges or individual users. And if you want to actually pull out the scores, you got to say with scores. Redis is really interesting that way in that it really is optimized. So a lot of times the data you'll get out of it will be very minimal. And that's just to speed things up. Because at high speeds, adding an array or extra data, pulling it out for thousands of users, millions of users can really slow things down. So it tries to optimize. And if in this case, if you want to get out the scores, then just simply pass in the with scores value, and it will then return the scores to you. Oh, I forgot this. Okay, so yeah, you add the 10,000 and then you get your value. All right, let's take a look at the next example, which is Geospatial Index. So Geospatial Index is a lot of fun, actually, because you can see the data on a screen, maybe on a map, and it's very useful. Lots of different websites use this for finding things near you. So the problem may be that you have many moving items within a geographical area. It doesn't have to be moving, it can be stationary. And you want to display real-time locations or just look for things nearby. You want to do this quickly. So what is the nearest item now, for example? And for something like that, SQL queries really are too slow. So with Redis, we can use the Geospatial Index, and you'd use the geoadd command to add an item to the to a key, and so you'd use Redis Geo. Is basically based on sorted sets, by the way, and so some of the commands actually do use the sorted set commands. So sometimes you can use like Z commands like zrange or zrem, and instead of creating a geo range or a georem command, they just use the sorted sets commands for those. But yeah, you can add your commands, you can find the distance between 2 points, you can find all of the points within a particular area. So let's take a look how you might do this. So here's some data from RedisConf, for example, and also from Rome, where perhaps Salvatore might actually fly out of, or maybe he can actually fly out of Campobello di Licata, where I think he's either from or it's near where he's from. And so in this particular case, what you can do is you can use the geoadd command to add you have a key called locations, and you're going to add in the latitude and longitude, and then the name of the location, okay? And then what Redis is going to do is behind the scenes, it's going to turn that lat and lon into an actual geo hash, or I forget the name of it, but a single value. It's no longer going to be a latitude and longitude. And so we're going to add Campobello di Licata, we're going to add Rome, we're going to add SFO, and we're going to add RedisConf. And then you can actually pull out that data if you'd like using zrange. You notice there it's not geo. Again, you're using the sorted set command because, again, Geospatial is based on the sorted set data structure, but we call it its own data structure because it has its own commands. And then you can pull the distance between 2 locations. So here we're passing in 2 locations by name, and we're asking for the data in miles. And then, or you can say just give me the location, the locations for two specific names, Redis Conf and SFO. Or you just want to pull out the hash values. You can pull out the hash value for one of them. You want to pull out the score. You can pull that out. And if you want to, let's see, in this case, if you want to pull out the radius, now all the values within a particular 15-mile radius of this particular latitude and longitude, you can do that. Or if you want to pull out the radius by a member name, you can pass in the member name, in this case, RedisConf. And you can say with distance and ascending. That'll tell you, actually give you the distances and in ascending order. And you can remove an item too. So, these are all the commands you might use with Geospatial. You can see it's pretty easy to do, even though Geospatial searches seem like they can be very complicated. All right, now let's quickly move on here to fire and forget with pubsub. Now, pubsub is, again, it's not really a data structure, but it is a very popular use case for Redis. And why is that? Well, the problem is that you've got to communicate with many. Let's say you're communicating with many users in real time. This can be like an example where you've got a calendar, a shared calendar, a community calendar, a company calendar, an event calendar, and a lot of people might have that calendar open in their web browser, and they're actively adding sessions or booking tickets or something like that. So you need to have this information in real time, otherwise you end up with overlap or duplicates and conflicts. So Redis pubsub is great for this. You're going to use the publish command to send out information to all of those who have subscribed to receive that particular information, and we call these channels. So here's just a quick example of how you can set this up. I put a little extra data here to show you how you set up your server. Just run the server, Redis server. In this case, what I'm recommending you do is run the keys. Now, in real life, don't run keys. Keys is going to give you everything, and you have large amounts of data that's going to essentially wreck your server, because you could be pulling out millions or even billions of keys. But what I want to show you, just if you've got some keys, if you're doing this demo at home, run your Redis servers, run the keys command, and then flush all. So flush out your data, and that'll delete all of your data in Redis, and now you can start from scratch here. And you can set up, for example, maybe 3 different windows on your terminal windows on your laptop. On the publisher terminal window, you can run this command publish channel 1, where you'll say hi 1. And now you'll notice we haven't set up our subscribers yet. So now step 2 and 3 is to go ahead and create 2 new terminal windows and run the subscribe command for channel 1. And you'll notice you don't get that data. Hi 1 is gone. We call this fire and forget. We published the data. It was sent out to all of the channels that have subscribed to it. There were no channels that had subscribed to it. That data is no longer there. It's like talking into the room with nobody in it. So now go ahead and publish channel 1 and hello 2, and now you'll see that subscriber 1 and subscriber 2 will both get hello 2. Now, just for fun, let's go ahead and cancel out your control, like use Control C or something to cancel out that subscription, and then do another publish channel 1. Only let's do hello 3 this time, and your subscriber 2 will be the only one that receives this information. So now go ahead and run your Redis CLI again and subscribe to channel 1 again with subscriber 1, and do a publish channel 1 hello world 4, and you'll see that both your subscribers will get that information. So I'm showing you this to let you know that the information can disappear, but there's a lot of use cases where this is really useful, where you just don't need to keep track of all the information. For example, if you're watching a web page or an activity, and as the video goes by, they're telling you what's happening in the video in real time, well, you might be saving that information somewhere else, but to all the web browsers that are open, you don't want to keep all that data on the page. You're just going to show, here's the words that are happening right now, maybe in a scrolling list or something like that. And if they shut down the browser and then reopen the browser again, then you don't need to show all the history there unless maybe they go to another web page where that information is being captured, but not the live page. So that could be very useful. Or if you're watching stock quotes and you just want to see what's real time, again, lots of use cases where this might happen. Maybe you're sending out configuration data to lots of different servers, and they just need to know what's happening right now. It's a very efficient way to do that. all the servers can subscribe to the changes. Okay, so but compare this to something like Streams. Streams is a relatively new data structure. It's the most recent data structure. It's been around for a couple years, but it's relatively new in Redis world. So with Streams, the problem is you want to communicate in real time with clients, but you don't want to miss any data. So for example, that server configuration example I talked about, it may be, depending on what the configuration data is, it may be critical that you actually get all of the data to the server, even if there's some hiccup on the network or something like that. And so we're going to use Redis, and it has some very simple commands: xadd to add an entry to a stream, and xread to pull an entry off a stream. Now there's also consumer groups with Redis, but I'm not going to have time to get into that. But that gives you the ability to acknowledge that items have been read and processed, etc. But let's go through here an example again. Now again, compare this to the example I just showed a minute ago with pubsub, where we're firing and forgetting. In this particular example, if you're going to set this up and run this yourself, you can see here we're going to add, step one is to add to my stream, which is our stream that we've created. And we're going to add that little asterisk, by the way, says, hey, server, you create the timestamp. I don't want to have all my clients or all my producers creating the timestamp. So you create the timestamp. And we're going to have a field called greeting, and the value is going to be hello1. Now, go to the consumer terminal windows and run the command xread count 10. So basically count 10 says give me up to 10 entries from a streams called mystream1, and start with the zero entry, or the first entry. And by the way, you can actually request entries from multiple streams. So that's why that streams keyword is there, and you can follow that with multiple stream names. And then do the same thing with consumer 2, and you'll see that both of these will actually output, you don't see it here on the screen here, but both of them will output that they've received hello1, even though it had been broadcast before these clients had actually been set up. Now let's go ahead and Control C, consumer 1, and we'll run hello world, or I should say hello 2 greeting from the producer, step 5, and then we'll go ahead and run xread on consumer 2, and you'll see that it gets both of those values. And let's go ahead and with consumer 1, you'll run the Redis CLI again, and I kind of went out of order here, but you'll xread, and you'll see that yeah, consumer 2 got all of those values. Then let's add the third hello world, or hello 3, and do xread from both the consumers, and you'll see that they get all of them. So even though consumer 1 was down when hello 2 was pronounced, when it comes back up and it asks for all the information, all the greetings, it will get all of them that have not been acknowledged yet. So it'll get all of them in this case. So an excellent way to send information out to lots of different clients in real time without missing any of the data. All right, so there's lots more examples. I'm not going to go through all of these in any more detail here, but just quickly, we talked about strings data structure for caching SQL queries or pages. We didn't really talk about bitmaps, but bitmaps are how you can store a key with a whole bunch of ones and zeros, and each one of those ones or zeros are uniquely addressable. So you can pass in a 2, for example, and get you back the 1 or 0 from from the placeholder 2. And this can be very useful for finding out, for example, what is the current on or offline status of all of your users. If you've got millions of users and you want to know user 1 just logged in and here's their 500 friends, please give me all of the friends who are currently logged in, you can pass in those 500 values or uniquely addressable values to the bitmap, and it can return back all the ones, which are all those that are currently logged in. So very efficient. Bitfield is somewhat similar, except for you can store an array of complex numbers, not just zeros and ones. Hashes we talked about, you can store basically field values. We talked about the user session. Lists, we can store ordered data for either fast data ingest or workflow, when we talk about that example. Sets, you can store unique values. We talked about the tags. You can store unique IP addresses, for example. As a bunch of visitors come to your website and all you want to know is unique IP addresses, just throw them all into a set and it will automatically just keep ignore the duplicates. This is great for things like cybersecurity or firewalls, that kind of thing. Sorted sets, we talked about that with a leaderboard. Geospatial index, we talked about that with finding a location near me. Hyperlog is an interesting probabilistic data structure. Try going to Google and search for Redis. It'll say that Redis is, I forget the number, but like 64 million references to Redis across the web. But there's a bunch of zeros at the end there, which tells you that it's, you're not going to have a lot of confidence that that's highly accurate, but it's certainly accurate enough to get a good sense. So probabilistic data structures are like that. They store large amounts of data in a small amount of memory, and they give you a kind of good enough estimate as to how many times a hyperlog will give you a good enough estimate as to how many times a particular word appears on the internet or in a body of text. And then we talked about streams, and and you compare that to something like pubsub, and you can see here there's a lot of different ways to scale out your website. Just depends on what problem you have and which data structure is most appropriate for that problem. Okay, well, we're going to wrap it up here, but before I do, if you want to learn more about these commands, you can go to redis.io/commands, and then you can pass in the key that you're looking for, but just go to redis.io and click on commands. Actually, that'll be easier for you. But it's all about the keys, and keys make it really fast. It's one giant namespace, so Redis doesn't have to look very far to find anything. There's really no long, SQL statements, so there's no querying, and there's no sub-indexes. It's just one giant index, and then inside of the data structures, there may be some indexes, like within a sorted set. But there's no schemas or anything that you have to worry about changing, so you don't have a DBA or anything like that that is going to be managing the table names and the fields and all that kind of stuff. Of course, the keys must be unique, just like you have primary keys in a SQL database. And that's it. So there's 10 plus different ways to scale out your website using Redis. And I don't think we're going to be able to take any questions here, but let me see if I can figure this out, how to do that. Let's go here down to questions. Let's see. I don't think we have that. Our chat. Yeah, I don't think we're going to be able to do that today. So if you have any questions, you can email me at dave@redislabs.com. And I really want to thank you for your time. In this 45 minutes, we covered a lot of ground here. And I hope you will join us at one of our Redis days, which are coming up, or Redis Conf, which is usually every spring. And this year it'll be in May. Thank you for your time.